It is June. It is Tuesday, June 23rd, and 9:54. Showing my face is fun. And holding a camera out with my arm held out, because I am so weak that even holding my arm up for 3 seconds causes it to be sore. Good job. I procrastinated, even though I told myself I wasn't going to procrastinate at all. Yes, I did procrastinate, but I only procrastinate for like 30 minutes or an hour. But then the thing that really made me lose a ton of time was I was trying to scan my work documents, but since I got a new computer recently, so it doesn't have the HP Smart app, and the Windows Fax and Scan app I tried using, and it was really stupid. Either it's really stupid or I don't know how to use it properly, because all I wanted to do was have multiple. I looked up how to do it, and somebody was like, "Oh, you have to create like some kind of TIFF file, whatever that is. I don't know what that is." So I just tried to re-download the HP Smart app, and then the Microsoft Store app was being really stupid, and so of course that took like a whole hour, and then I finally scanned the document. The point is that now it's 9:50 something, so I'm gonna do a math assignment, because now it's randomly now due on Wednesday instead of being due on Saturday. I have to do 20 questions just as usual, and I have to read 4 sections of the textbook, and so let's see. So I was trying to do. Here's what I was trying to do before. So I was trying to finish it all in one day, but that's too stressful, because then I feel like I'm under too much pressure. So I think I'm not going to do that for what I'm going to do instead. But this doesn't seem to be working too well either, because I haven't even started. I got up at 6:50 and now it's 9:50. It's 3 hours. Basically what I was going to do is just try to work at a good pace, or basically just try to work on it for a specified amount of time, which is technically all day today until 6, but of course I already wasted 3 hours, and I keep not being motivated to do it. I'm just not motivated. I just don't want to do it. But anyways, I'm gonna at least, goal is just to work on it and get a lot of it done, and work on it all the way until 6, and only take small little breaks to do whatever, like maybe eat lunch and maybe a couple of little small breaks, and that's it. Dang it. My work ethic is so terrible. I just cannot motivate myself to do anything productive. So that's what I'm gonna do. Wow. Whoops. The first thing I'm going to be doing is reading section 12.1. It says evaluate the integral, evaluate the integral, evaluate the integral, evaluate the integral, evaluate the integrated integral. What? An integral of an integral? Oh my gosh. Oh wait, duh, that's just like a double integral. Duh, you just do it twice. Not that hard. Oh my gosh, evaluate the integrated integral. That's 6 questions. Good job. Let's see, iterated integrals, area of a plane region. Don't have to do anything for the area of the plane region. So I'm just going to read this section about integrate the integrals. And also, I've decided there's a more efficient way to read sections. I don't have to read the entire thing. Well, I was already doing it slightly more efficiently before, but now that I realize I have this resource, all I'm really going to do is look at the tables that have all the formulas and stuff, and look at the example problems in the section. I'm not going to read anything else. I mean, that's what I was doing before, but I can also rely on this thing if I'm getting stuck on a question instead of having to look at the textbook. So that should make everything go much more quickly. So let's see. I should not set goals for the time of how long it takes, because then I feel too stressed out. I sound so weak. My work ethic is so lazy. But seriously, that's how I feel. Like, I feel too stressed out. It's like, oh, and then when the time it goes over, sometimes it's not even my fault. It's just that it takes longer to learn something. But I will at least make an estimation of how long it will take. So just for watching the video, you'll see how well I'm actually doing here. In that situation, in that case, maybe we should make an estimation of how many problems I'll be able to finish. Well, what I want to do is finish the whole thing today, because I can do it really quickly as long as I'm very efficient. But that's really optimistic, and I don't really know if that will happen. And I was doing the midterm, and I knew all that information already, and yet it took all day. It took like 2 days. So here's the actual estimation of how much I'll get done. I'll get done maybe the absolute worst possible case is that I only get half of it done. Maybe about an average estimate is that I get 75% done, and then an optimistic estimate is that I get the whole thing done. So that's my range, either 50% or 100%, or somewhere in between there. I'm probably going to get that much done today. So that means 10 to 20 questions I'll finish. So that's my estimation of how long that will take. How long will it take me to do the first section, read the first section, and then answer the 6 questions? I think that will take probably, at the very most, it will take 1 hour. 1 hour to do 6 questions. 1 hour to do one section. The first of 4 sections. So 1 hour. And then 6 questions. So I will estimate that I finish at 11:03. So, yep. I will maybe update you. I don't know. I don't even know. I'll just update you whenever I feel like it, and then let you know. So it is now 10:03. It is 10:07. So I finished reading 14.1, and so it looks really easy to me, because you basically just do a normal integral, but you only do it with respect to one variable, which I've already been doing with derivatives, so it should be very easy to do with integrals. The only problem is I might forget how to do complicated integrals that I learned how to do in Calc 2. So if that happens, hopefully I can kind of figure it out. I might have to look at my textbook or something to figure it out, or maybe even just look at the solution on this thing. But yeah, it shouldn't take... I estimate that I will be able to get these questions done in half an hour or less, which means I will be able to finish it by 10:38. So I will do 1 through 6 and let you know when that's done, and it's 10:08. It is now 11:49. So I finished 1 through 6. And I was hoping it would take only half an hour, but it actually took over an hour, because I will explain, but let's just go through. That one was so easy, just really easy integral. This one was also easy, except I kept messing up because I kept being really stupid and doing it wrong, but I eventually got it. And then number 3 and 4 were really difficult, because they were basically let's see, could I have even used substitution on that one? X, U, and then U over, and then X, wait a minute. What is the derivative of ln x? It's 1 over x. I'm stupid. I could have used substitution on this one, but I didn't. Instead, at least I figured out how to use substitution. So basically, there are techniques for integrals that I learned a long time ago, but I totally forgot all of them. I think all I had to do for that, because I could easily do substitution, because the derivative of ln x is just 1 over x, right? Derivative, you take the derivative first. Yeah, because if you do du is equal to ln x dx, or no, u is equal to ln x, du is equal to 1 over x dx. Yes, you could have easily used substitution on that, but at least now I know that. But so it's very simple. It's a very simple technique called substitution for that question, but I didn't know that. So basically, I went to the table of integrals at the back of the book and looked at it and just typed, and then just used that to solve it. Anyways, that took a while to figure out. And then the next question was actually an even more complicated process of integration, because you have sine 3x. So you have to use this weird thing that is over here. It's called I don't know, there is no name for the process. It's just a way to evaluate trigonometric integrals. And you use this stuff up here. You basically change, if you have a sine x and a cosine x, you basically do a process where you change it so both of them are either cosine or both of them are sine. So, and you use a trigonometric identity to change sine x to 1 minus cosine x, or something to that effect. And then you use substitution to solve the integral. So, the point is a very complicated process that I totally forgot how to do, and I had to relearn the process by looking at my old textbook. If I didn't have this textbook, I don't know what the heck I'd have to probably look in that textbook somewhere, which I have no idea where I would be looking, but it would probably be somewhere in that textbook. But I'm glad I still kept my old textbook, because I can refer to it to look back at things I learned years ago. And because, yeah, I mean, technically, I should have probably just taken Calc 3 right after Calc 1 and 2, but I didn't. I just waited forever until the very end of my NICC, years, and then I was like, okay, well, it's down to the wire, and it's either Calc 3 or literature, so I guess it's going to be Calc 3, but it was just such a pain to have to apply to some other college to take it, because NICC doesn't have it. All that to say that it's been a long time since I took Calc 1 and 2, so I forgot a lot of the stuff I learned in Calc 1 and 2, and now whenever I come to a question in Calc 3 that requires knowledge of Calc 1 and 2, and I forgot that knowledge, I have to refer to the textbook, and that textbook isn't very good, but at least it's better than this online textbook for Calc 3. Like, I didn't think it could get any worse than this textbook, but actually, the textbook, our online textbook for Calc 3 makes this look like a Saxon textbook. Like, I made that comparison before, but it just makes this textbook look way better. Okay, I need to stop. So I used that technique to solve number 4, and I'm so glad I got the right answer, because, man, that could have been bad. And then number 5 and number 6 were easy because they were just simple integral. They were simple because they just wanted you to be able to do iterated integrals. But iterated integrals are easy because you just do one integral and then you do another integral. That's all it is. You just do the inside and then you do the outside. Okay, now it's time to do 14.2. So it's something to do with approximating the integral by dividing the rectangle. Wait, why is it rectangles? Are you kidding me right now? Why would they make you do this? I remember doing something like that in either calculus 1 or 2, but this time we're doing it for quote unquote 3 dimensions, but is it 3 dimensions? It says it's a rectangle, so it's not 3 dimensions. I don't know why. I really hate that they make you do that, but that's what we're doing for those. So estimation. I don't even know how long this is gonna take. I'm just gonna say it's gonna take an hour to do the whole thing. Please just take 1 hour. I have to read like probably this section. So I'm hoping that this will be done by 12:56. So it is now 11:56. It's 12:11. And I tried to read this section, and I think I might understand what I'm supposed to do. So I will now try to do 7 through 10. It is 12:11. It is 1:01, and I'm actually done with 7 through 10. It actually took about 1 hour to do it. Nice. So for some reason, I found that the concept I had to learn for these questions was actually not too difficult, because I already know how to do double. I call them double integrals, but they're actually called iterated integrals. You basically just have to do a bunch of iterated integrals and then relate that somehow to a graph or whatever. It's pretty easy. And they want you to also approximate the answer by relating it to a graph and creating boxes and then like adding up, doing some kind of weird thing where you add up this thing right here to get an approximation, which is probably a way, maybe it's a way a calculator can do an integral, or it's a way a computer or a calculator can do an integral. But anyways, yeah, that's pretty much all I had to do for all the questions. Like iterated integrals, I think, yeah, I already did that in some of those other questions, and it's really easy. You just do the inner side integral and then you do the outside integral. Yep. So I did that. Also, for these, I had to basically do that thing where you draw the thing on the graph and then you take all those center points and you put them right there, and then you apply that to the function and you add them up, multiplied by the area of each box, which was 1. So it was pretty easy. And for these two, you kind of had to relate it to the graph. And I was a little bit confused. This one is easy because it's like x is from 0 to 1 and y is from 0 to 2, so that's just this rectangle. And then this one I was a little bit confused because there's no rectangles, because the y is from 0 to 9 and then the x is functions of y. So, but then I was able to figure out, oh, so the beginning of it is 1/3 y, and that's this line, this diagonal line, and then the square root of y, I'm guessing, is just this curve right here, so that would be this one. So that was not too bad. Voice crack. And then obviously the iterated integral, and then I got the answer, and yep, so that's what I did for 7 to 10. So the next section is 14.3. I did not really look at this yet. Probably look at it. I'm gonna just go eat lunch first, and then I'll look at that. So it's 1:03. It is now 1:56, and I made questionable decisions as to what food I would eat for lunch, and now I feel really stuffed. But anyways, so we're going to start on 14.3. So I guess we can kind of talk about how our progress is going. We started around like 10, I think, or maybe 9 something, and we're already halfway done. So maybe we can even finish the entire assignment today. That would be really really cool, because then, yeah, then I wouldn't have to work on it another day. I could all be done one day, and since we've already gotten half of it done, we have it's 2 o'clock now, and maybe we can get the rest of it done in like at the very latest 6 o'clock, but maybe even sooner than that. 4 hours should be enough to read 2 sections and then complete the questions for those 2 sections. So yeah, I think our optimistic goal of finishing in one day might actually be realized. And to be honest, when I'm looking at this 14.3 stuff, it looks quite easy because it's just the same thing I've been already doing, but maybe some kind of way to convert this to polar coordinates. I'm guessing they want you to say polar. Guess I could do 11 without reading anything. It's so easy because look, it's the shape. I recognize the shape. You can get this shape using, and it's something to do with polar coordinates. And that's obviously what you do, because why would it be rectangular? Why would it be rectangular? It's a new section, and it looks. I remember doing this in like Calculus 2 or something, where you could make these shapes really easily using polar coordinates. So I'm already done with one of the questions. That was so easy. Oh my goodness. But then we have this short question, which is also a multiple choice question, but I'm not entirely sure. 3. I remember doing this. If there's 3 of these, it means something. Like you can represent it by using certain numbers, like maybe the number 3 with sign. I don't know. I really remember doing something like this in Calculus 2. I just don't remember exactly what. There's 3 and then there's the number 8. I don't see. Oh, so the ends of them seem to go down to 8. Basically, like x is equal to 8 over here. So these things are like 8 long. So that translates down to this in some way. I just don't remember exactly how it does. So I'll have to probably read the section to get that question. And then all these are just evaluate the double integrals, and you probably have to convert it to a polar coordinate maybe first. I don't know. That's what I'll find out. So I will now read 14.3. It is 1:59. Yeah, it's only a few minutes later. I didn't actually read the section yet, but for the next question, I looked at this video that explained how to do the question. So basically, you see that if you look at the shape, you see that this is 4 wide, and so that means you put the coefficient of 4, and then I explained how it had to do with cosine. I can't remember exactly what it was. I probably should know that. Maybe, wait, hold on a second. So yeah, this is probably not the best or most precise way to think of it, but basically, if it's a sine, then the one that's basically right on the it's right on the axis. It's on the y-axis. That one of those shapes is on the y-axis, so it's a sine. And this one of those shapes is right on the x-axis, so it's a cosine. So I know that's not the most precise and exact way to think of it, but I just like to make shortcuts for things, and that's one shortcut way to think of it. So basically 4, the length of this thing is 4. Cosine, one of them is on the x-axis, and then 3 theta, there's 3 of them, so 3 shapes. So that's how you would do that question. So it's the same thing except different numbers. So r wait a minute. And but that's not all. So hold on a second. I think so. R is actually like the radius. So R is the radius. So the radius can be described as, so this is 8 long, so it's 8 times cosine of 3 theta So cosine of 3 theta, so if you plug in a 0, or if you plug in 1/3 for theta, it's cosine, I don't know what. So r is the radius, and the maximum radius is 8. And then the maximum value of inside the cosine, I guess, is 1, so it'd be 8 times 1. So that's the maximum radius. So 0 to 8 cosine 3 theta, and then theta is in between. So yeah, since it's on the x-axis, it's the cosine. That's the only difference between these two. So the right answer is this, because the radius is 8. It's cosine because it's on the x-axis. 3, if there's 3. And theta is between 0 and pi because it only goes around in 360 degrees. Pi, when you convert it to the... I'm stupid. When you convert it from radians to degrees, pi is 180, or pi is, wait a minute, shouldn't it be 2 pi? I don't know. You would think it would be 2 pi because this is 180 degrees, but maybe this is what I don't know, I'm not sure, but basically that's what it is, so that would be the correct answer for that one. So I didn't even have to read. I just did 2 questions without even reading the textbook. Because there were tutorials on both of the questions, so it was really easy. Now, the real challenge will be doing these. Basically learning how to do an integral, learning how to convert something to polar coordinates first, and then do the integral. So I will now read the section to learn how to do that. It is 209. Still reading the section, but I just wanted to explain something. I just realized the reason why it's just to pi instead of 2 pi is because if you do this function, it will actually basically make the shape twice. So after 180 degrees, it will make it once, and then after another 180 degrees, it's twice. So that's just how this particular one works. So that's why this is, it's just 0 to pi. Anyways, we'll continue reading. This section is 214. It's 229. I finished reading the section. I got a little bit distracted, but yeah. So basically, you just got. This is like how you would do it. You kind of use this right here. So you have f r cos theta, r sine theta. Wait, there's cos and sine. Wait a minute. So you basically replace the x with r cos theta, and then you replace the y with r sine theta. Yeah, that makes sense. So you have, and then the limits are, okay, they made the symbols really complicated, but basically the limits are, the outside one is the limit of the theta, and the inside one is the limit of the radius. So, and then you multiply that by r, and then dr d theta. So the integral could be kind of involved, but hopefully it's not going to be too bad. So I think I know how to do it now, kind of. There's also this watch it thing here. But probably the best way to do it if I get stuck is look at the answer key here. So this question is related to number 17 for section 3. So this will help. Wait, what? Rectangular coordinates. Wait, just a sec. This is 14.3, 17. I'm stupid, I didn't even click 17. So it's related to number 17, and it gives me, this will basically help if I get stuck, or I can just refer to it to make sure I'm doing it correctly. Now they do use different numbers, so I won't be able to follow it exactly, but it will be definitely helpful. I probably wasn't even showing it. I was probably holding it out of frame. Whoops. Dang it. So I'm going to predict that I will finish. Okay, here's a very optimistic prediction. I will finish both of these questions within half an hour. So that means about 3 o'clock. So yeah, hopefully I can finish by about 3 o'clock. And as you can see, it's currently 2:32. It's 3:12 and I finished the questions. So yeah, I guess I kind of did the first two already. I kind of showed you those already. Wait. Oh no. Never mind. I accidentally skipped number 13. I'm so stupid. How did I skip that one? How did I skip 13? No. Oh no. Okay, never mind. Well, I did. Okay, never mind. I will now do 13. It's 3:30. Voice crack. I finished 13. Oh my gosh. I had trouble with 13 because why did I have trouble with 13? I had trouble with 13 because it was an integral of cosine it was an integral of cosine squared theta, and when you do that, you have to use the identity cosine squared theta equals 1 plus cosine 2 theta over 2. Oh yeah, and I also had trouble because I was confused about the graph thing, but I'm stupid because it's the same logic as before, except in the theta, you use this thing up here, this 7 cos theta, and then you see the theta, the in front of the theta, the coefficient is 1, so there's only one of them, and then the 7, the radius is 7, and so yeah, that's simple stuff. So yeah, we're finally done with that. Jeez, took forever. Now we just need to do 16 through 20. Find the mass of the lamina described by the inequalities. Well, that seems... Find the mass and center of mass of the lamina corresponding to the region R. Yeah. Translate the given lamina to the right 9 units and determine the resulting center of mass. Find the mass and center of lamina, bounded by the graphs for the equation. So it doesn't look like it has anything to do with multiple integrals, but it probably does, because that's the entire point of the chapter. So I will read section 14.4 and it's 13. I mean, it's 332. It's 338, so I read the section. So basically, you have to find the mass by using this equation, which is the double integral, and then this symbol is the function basically, and then or p of x, y, so you just use the function. So and the limits, yeah, you just do the same things before. It's just basically the same thing I've been doing already, but it's an application to some kind of problem relating to mass. Then the other thing is the center of mass is you basically find the moment of mass for x and y, which is those things. Why is the y in parentheses? I don't know why. I don't know why the y is in... Oh, I think I know why. I keep making the pun. Oh my goodness. They didn't want you to be confused to combine it with the p function, so they just put it in parentheses. So, the moment of mass. It looks very similar, except you just put the y right there, and then you put the x right there, and then the center of mass is each individual point is what you came up with divided by m. Wait, what is the m? Dang it. M is the mass. You have to find the mass of the lamina, and that's the on the m. Yes, excellent. Why? Okay. So now I don't even know. How do you translate the lamina of 9 units to the right 9 units? How? What does that even mean? There is no explanation of how to do that. There is no explanation. Is it something to do with the moment of inertia? I doubt it. I'm pretty sure it's not. So, whatever. It probably just means if they didn't explain it, they think that it's too simple. It's too simple to even bother explaining. Great job, textbook. So now I will try to do all those questions. I don't even know how long it's like. Maybe I'll just try to finish before like 5 o'clock, which is an hour and 20 minutes from now. It's 3:41. It is 6:02. Okay. I've been struggling for like the past how many hours on this stuff. When did I start doing that? Like 4 something? No, 3 something. I've been doing this past. Wait a minute. I'm pretty sure I started working on 15 to 20 or 16 to 20. I'm pretty sure I started working on it at like 3:20 something or 3:40 something or something. So it's actually been like 2.5 hours, unless I'm misremembering what time I started it. But oh my goodness, 16 was easy. 17. I did it 3 different times, and I triple checked and quadruple checked, and I still don't know why I got that wrong. I don't know why. So that's wrong. So I have to message my instructor, and I really hope he responds. And if he doesn't respond, I'm just going to have to keep on looking it over and over and over and over again until I finally figure out what I did wrong. But I already did that, so I still don't know what I did wrong. Number 18. A lot of it, I decided just to kind of skip over it because I kind of know what to do already. I feel like doing a bunch of busy work that's completely unnecessary. So I kind of sort of copied the answers from the book, but I know how to do the problems, so it's fine. And I had to do it for number 19 too, except for this last one. I did a bunch of work for it, and I spent 10 billion years getting that answer, and it's still wrong. And that's yet another question. I still don't know why it's wrong. Now, I didn't go over it as many times as I did 17, but that's just because of how long it took. Like, it took me forever to get that result, and I still got it. The result is still incorrect. So I'm also going to message my instructor about that one. And number 20, I did it first try. So I obviously know how to solve these types of problems. It's just that there's some random thing I'm missing for number 19C and for number 17. Like, I was able to do, I mean, technically I didn't really do number 18, but I did number 20. I did that just fine. I did number 16 by myself, and I did that just fine. So just don't know why I got 17 wrong. And I don't know why I got 19C wrong, so I need to message my instructor. This is why you do your assignments ahead of time, kids. It's because if you wait till the last second and then you don't know how to do it, you're screwed. So now I have to message my instructor. So I am done with the entire assignment except for 1.5 questions or something to that effect. I have 18.66 divided by out of 20 points. So I just need those last little few points at the end. and then I'll be completely done. But unfortunately, I have to ask my instructor in order to finish the assignment. So I'm hoping he responds, man. If he doesn't respond, oh my gosh, I might not even get 100% on this assignment. But he's responded to all my past questions, so hopefully he will. Like hopefully he reads it like tomorrow morning or something, and responds to both of them, and then I can, even if I don't understand, like the last couple times I asked him some questions, sometimes I didn't even understand his explanation, which is hilarious. Like you're supposed to make the person understand with your explanation, but somehow I still didn't understand it. But maybe this time I'll catch some kind of mistake I made in reasoning, or a mistake I made in just my math, or somewhere I made a mistake. But number 17, I am almost certain I didn't make a mistake for that, so I have no clue. Like, I could see myself making a mistake for number 19C somewhere, but for 17, I am genuinely confused as to why that is wrong. So anyways, that's it for today, man. I spent like all day on this. I mean, technically I didn't start till like 10, but still. Like, it's 6 o'clock. But luckily enough, I'm on the brink of finishing. It's just those last two little things. So I guess tomorrow, what I'm going to do tomorrow is finish up the math, and then I'm going to work on my computer class, because I am falling behind. Every day I don't work on it, I'm falling farther behind, so I definitely need to go and do that stuff for my computer class. So yep, that's all for today's stupid, idiotic vlog. Goodbye.